Hello, today we're going to start on, we're going to finish up special right triangles. And so I would love you to do this warm up if you haven't already on your own. So please pause and do these if you haven't. Okay, welcome back. So you should have done them already. So I'm going to do this pretty quickly. But again, the hypotenuse is across from the right angle. So 3 squared plus x squared, equals 6 squared. Okay, so x squared, and I'm going to skip some steps, but 36 minus the 9 is 27. So x is the square root of 27. Now, a perfect square that goes in there is 9 times 3. Square root of 9 is 3, so you get 3 root 3. Second one here, again, the c value here is the hypotenuse. And you get that. So 64 minus the 16 is equal to 48. So x equals the square root of 48. And again, 16 goes into that 3 times. So you get 4 root 3. Okay, last one, 5 squared. This is c again. Okay, so x squared. This is 100 minus the 25 is 75. So x equals square root of 75. That is 25 times 3. And thus 5 root 3. Now there's some patterns going on here with these numbers and the lengths on the triangles. So things to look at here, the short leg on all of these is this side. So that short leg has a relationship to the hypotenuse. And the hypotenuse is this guy on all of these. So what you can look at here is how are those related? From 3 to 6, from 4 to 8, from 5 to 10. So it should be fairly obvious that they are doubled. So if you do the short leg times 2, it's the hypotenuse. Okay, last thing you have is the long leg. So the long leg is obviously the last guy here. And there's a relationship between the short leg and the long leg as well. So if you're looking at the short leg to the long leg, this is 3, now this is 3 root 3. This is 4, this is 4 root 3. This is 5, this is 5 root 3. So in this case, you take the short leg and you times root 3, and that gets you the long leg. This pattern occurs whenever you have this relationship of a right triangle with the short leg is 5 and the hypotenuse is double. You are always going to get that root 3 relationship as well. Okay, these are called 30, 60, 90 triangles because in this scenario, you're always going to have a 30-degree angle and a 60-degree angle with the right angle. So, summarizing, in a 30, 60, 90 triangle like above, the long leg is root 3 times the short leg. And in a 30, 60, 90, the hypotenuse is 2 times the short leg, just like we talked about above. Okay, there is a quick, and I'll just do it super quickly, but a quick example of why that works. If you draw yourself in a big equilateral triangle like this, these are 60, these would each be 30, and this is 60 as well, because in an equilateral triangle, all of the angles are 60. Notice that you end up with two 30, 60, 90s. So basically what happens here is a hypotenuse is C, while in an equilateral triangle, this is also going to be C, and this is your short leg, and I'll just put an A here and an A here. But anyway, the short leg is half of the hypotenuse. Okay, and then you could go into some further detail about the root 3, but this is the main thing. So if you draw this equilateral triangle, that means if this is C, this other length down here is C, and each of those is A. So that's why you get that double, or 2 times the short leg is the hypotenuse. Okay, you do always want to start with the short leg when you're calculating. So just like I drew the arrows above, you want to, from the short leg, times 2 to the hypotenuse, from the short leg, times root 3 to the long leg. Now, a good way to remember that it's times 2 is you can rename hypotenuse and call it hypotenuse. So you have that 2, it's times 2, hypotenuse. Okay, that's a good way to remember. All right, so we're going to try some of these examples just using the shortcut. So the first thing you always want to do is identify where the short leg is. The short leg is always across from the 30-degree angle. It's from across from the smallest angle. So here, 15 would be my short leg. Let me just make sure I'm highlighting with the same color. No. So let me do that in green just to be sure. Okay, so the short leg here in green is 15. Hypotenuse is going to be y, hypotenuse, so times 2. So I know y is going to be 30. Okay, and then going to the long leg is times root 3. So this is simply just 15 root 3. So notice I don't even have to calculate anything, which is nice. Okay, you can just use the shortcut whenever you see a 30, 60, 90. All right, on part B here, so if you have evidence of a 30 or a 60-degree angle in a right triangle, then you can fill in the third angle. If you don't know either a 30 or a 60, you can't just randomly put in angle measures. That's one of the big mistakes people make. You have to have evidence that it's a 30, 60, 90. Okay, but the short leg here is going to be across from the 30-degree angle. The hypotenuse is across from the right angle, hypotenuse, so times 2. So this one's a little more difficult. 13 root 3, when you multiply by 2, you just multiply the outside number here, the whole number. So 13 times 2 is going to be 26, and then you just copy the root 3. Okay, this is also a little more difficult in this case. So now I'm going to do times root 3, do it off to the side here, but you do 13 root 3 times root 3. Well, that is going to be 13 root 9, which is 13 times 3. Root 9 is equal to 3. So 13 times 3, you can use the calculator, is going to be 39. So here the y value would be 39. Okay, the next scenario. So again, you have a 60-degree angle and a right angle. So therefore, I can write in the 30. Okay, so I know that y is my short side. And across from the right angle is 14. So you always go from the short side. So hypotenuse, so times 2. So something times 2 is 14. So that something should be 7. So you're actually, when you're reversing it, you're dividing by 2. But just think about something times 2 equals 7. So that's got to, or equals 14. That's got to be a 7. Okay, and then using the pattern, you times root 3. So this is simply 7 root 3. Okay, the next one, again, obviously you have a 90 and a 60. Therefore, I can write the 30. The short side is across from the 30. Always go from the short side. So hypotenuse. So here I'm going to do 23 divided by 2. So what is that? 11.5. You could also just write it as 23 over 2. That also works. And then you take that number times root 3. So I am just going to write it as 23 over 2 root 3. Okay, last scenario. So again, there's a 60 in there. I'm going to write the 30 here. Again, the short side is across from the 30. The hypotenuse is across from the right angle. So this is hypotenuse. And here, I don't have a variable or a length on either one of these, so I can't really start with this. I will have to start over here, but that's times root 3. Okay, these are the hardest ones. When you are given a length on the long leg, these are the most difficult. Okay, and actually I'd prefer to start with this one, so I'm going to skip over to this one and then I'll come back. This is the hardest version right here. Okay, so here that would be a 30, so this is my short leg. Okay, hypotenuse, so I don't have numbers there, and then this one would be times root 3. Okay, so this one's slightly easier. So I need y, so basically y times root 3 is equal to 4 root 3. So something times root 3 equals 4 root 3. So hopefully it's fairly obvious that has to be a 4. So this y value is going to be 4, and then you simply double it and you get 8. Okay, another way to look at it is when you're working backwards, you just take 4 root 3 and you divide by root 3. Okay, and those will cancel and then you just get the 4. So this is another way to look at it, and that's what we're going to do on this one. This one's the harder one. Okay, so starting from the long leg, because I have a 9 there, what you're going to do is, I'll do it here, you're going to do 9 divided by root 3, and that's equal to y. Now, as we've talked about, you can't have a root 3 in the denominator as a simplified form. So now we have to rationalize. That's why this makes it the most difficult version. Okay, so now I have 9 root 3, and then root 3 times root 3 is simply 3. And then that simplifies 9 divided by 3, both outside the radical, simplifies to 3 root 3. Okay, so the y is 3 root 3, and then you times by 2, so 2 times 3 root 3 would be 6 root 3. Okay, but 100%, this is the hardest version. If you can do this one where you just divide by the root 3 with the root 3, I'd be pretty happy at this point. Okay, so this one is difficult. Okay, last thing, there are some other mixed practice. So things that you want to look at here, 30-degree angle, 90-degree angle, so I can fill in that this is 60. And then from there, you still want to identify your short side, which is here, right? This one, same thing, short side is here. This one, short side is here. This one, short side is here. So that is the first thing. Obviously, with these mixed, is a mixed practice. Hypotenuse is going to be 6, and then this is 6 root 3. Okay, this one has the root 3 in the long leg, so this guy is going to be 29, and this will be 58. Okay, but we will go through the rest of these in class tomorrow. See you next time. Thanks.